Welcome to the DIY Honda Garage channel. The DTC P2647 indicates a problem with the variable valve timing and lift electronic control (VTEC) system, which is an integral part of the engine's performance in the Honda Civic models 2006 to 2011. The VTEC system helps optimize engine efficiency and power output by adjusting the timing and lift of the engine's valves based on speed and load conditions. When this error code appears, it signifies that the VTEC system is stuck in the on position, possibly leading to performance degradation, reduced fuel efficiency, or engine noise. Key components directly involved include the rocker arm oil pressure sensor (EOP sensor) and the rocker arm oil control valve, which control oil flow to the VTEC system. This issue can arise due to malfunctioning components, inadequate oil supply, or electrical faults affecting communication with the engine control module (ECM). Understanding this DTC is crucial for both diagnosis and repair to ensure the overall health of the vehicle's engine system. The variable valve timing and lift electronic control (VTEC) system plays a critical role in enhancing engine performance, particularly in Honda Civic models from 2006 to 2011. The EOP sensor, or rocker arm oil pressure sensor, is crucial in monitoring the oil pressure required for the VTEC system to function correctly. Located in the engine head area, the EOP sensor detects the oil pressure and communicates this information to the engine control module, ECM. The rocker arm oil control valve, also positioned in this area, regulates the oil flow to the VTEC system based on the commands it receives from the ECM. If the EOP sensor fails, the system could either remain locked in the on position or function erratically, resulting in the P2647 error code. The proximity of these components is essential for proper diagnostics, as any oil flow blockage or sensor error can lead to VTEC malfunction, ultimately affecting vehicle performance. Understanding the possible causes of DTC P2647 is crucial for effectively troubleshooting the VTEC system. A low engine oil level can lead to insufficient hydraulic pressure necessary for the VTEC's operation, triggering this error code. Another potential source of the issue is a malfunctioning rocker arm oil pressure sensor, EOP sensor. If it fails, it may incorrectly relay pressure readings to the ECM, leading to a VTEC system stuck in the on position. Additionally, a faulty rocker arm oil control valve can restrict oil flow and cause similar symptoms. Lastly, electrical connection issues, such as loose terminals or corroded wires, can disrupt proper communication between components like the EOP sensor, rocker arm oil control valve, and the ECM. Identifying and addressing these causes is fundamentally necessary for rectifying DTC P2647 and ensuring optimal engine performance. When DTC P2647 occurs, drivers may experience several noticeable symptoms impacting the functionality of the Honda Civic. One of the most immediate effects is reduced engine performance. The vehicle may feel sluggish during acceleration due to incorrect valve timing. This change can lead to increased fuel consumption because the engine is not operating at its most efficient state. Additionally, unusual engine noises may arise, particularly if the VTEC system is stuck engaged, generating rattling or knocking sounds not typically present during normal operation. Finally, there may be significant VTEC engagement issues, causing it to either fail to activate or remain active regardless of engine conditions. These symptoms not only impact the driving experience, but also signal the need for immediate diagnostics and repair to maintain the vehicle's optimal performance. The first step in troubleshooting DTC P2647 involves checking the engine oil level, as this is a foundational step in diagnosing VTEC-related issues. Proper oil level is crucial for all hydraulic systems in the engine, including the VTEC, as it directly affects oil pressure. If the engine oil level is found to be below the designated mark, it can lead to insufficient oil flow and create pressure issues. In this scenario, if the oil level is low, the immediate action is to refill the oil to the appropriate level and subsequently proceed to step 11, as indicated in the diagnostic instructions. Conversely, if the oil level is satisfactory, the technician should move on to the next step to continue the diagnosis effectively. Monitoring engine oil levels routinely is also an essential preventive measure to avoid such complications. For the second troubleshooting step of DTC P2647, the technician must turn the ignition switch to the on position, which is crucial in preparing the vehicle's systems for diagnostic work. This step allows the electronic control module, ECM, to power up and enables communication with Honda's diagnostic tools, such as the HDS, Honda Diagnostic System. Ensuring that the ignition is on without starting the engine prepares the vehicle's electronics for the next diagnostic test. This procedure is standard practice for initiating any electronic component examination and should always precede accessing diagnostic functions. After turning the ignition to on, technicians should then proceed to the next troubleshooting step to continue assessing the VTEC system functionality. In this troubleshooting step, the technician is tasked with clearing the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS. Clearing the DTC is essential for resetting the engine monitoring system and creating a clean slate for subsequent tests. It helps ensure that any previously stored codes and data do not interfere with the current diagnostics. After clearing the code, the technician prepares to conduct the VTEC test in the inspection menu, which will assess the functionality of the VTEC system under controlled conditions. This step is a pivotal part of the troubleshooting process, as it directly investigates whether the system is functioning as intended after any potential reset. By performing this step, technicians will gain more accurate insights into the current operational state of the VTEC system, without the influence of past errors. The fourth step involves conducting a VTEC test using the HDS, which is crucial for directly assessing the operational status of the VTEC system in real time. This test evaluates whether the system is responding appropriately to commands from the engine control module, ECM. If the result indicates that the VTEC system is functioning correctly, it can signify an intermittent failure, meaning the system performed well during testing. But there may be underlying issues like poor electrical connections. Technicians are advised to inspect connections or terminals, particularly those linked to the rocker arm oil pressure sensor, EOP sensor, and the rocker arm oil control solenoid. Should the initial test fail, the technician will then move to the next troubleshooting steps to isolate and resolve the issue more effectively. This form of testing helps ensure that all components are working harmoniously, which is crucial for optimal engine performance. For the fifth troubleshooting step in diagnosing DTC P2647, the ignition switch must be turned to the lock position, which is essential before any physical inspection or part removal can occur. This precaution ensures the safety of the technician, preventing any accidental engagement of the engine's electrical systems during the process. Turning the ignition off also prevents potential damage to the vehicle's electronic components, particularly during the removal of sensitive parts like the rocker arm oil pressure sensor, EOP sensor. Once in the lock position, the technician should prepare to remove the EOP sensor for further inspection and testing. This step is fundamental in basic electrical and mechanical safety protocols, ensuring that repairs are carried out without risks of injury or system damage. Step 6 involves the removal of the rocker arm oil pressure sensor, also known as the EOP sensor. to facilitate further examination. This component is integral to the functioning of the VTEC system, as it monitors the oil pressure and provides important data to the Engine Control Module, ECM. The technician is required to attach several special tools, including the oil pressure gauge adapter, to carry out precise measurements on the oil pressure. It is crucial to ensure the correct installation of all components, as improper handling may lead to leaks or inaccurate readings. After removing the EOP sensor and connecting the necessary adapters, it is recommended that the technician follows the manufacturer's specifications, using new O-rings to secure proper seals during reassembly. This careful handling of the EOP sensor is vital for ensuring that the VTEC system operates within its intended parameters. In the 7th step, the technician is instructed to start the engine and maintain the speed at approximately 3,000 revolutions per minute, RPM, without any load applied, meaning the automatic transmission should be in park or neutral for manual transmissions. This phase serves to elevate the oil pressure in the engine to simulate operating conditions under which the VTEC system would normally engage. Holding the engine at this speed allows adequate time for the hydraulic components to reach operating pressure levels and is critical for accurately testing the functionality of the VTEC system. The radiator fan will typically engage during this time, indicating the engine's thermal management system is functioning as expected. After maintaining the engine speed for a duration of 2 minutes, the technician should allow the engine to idle before proceeding to the next testing step, ensuring all conditions are met for accurate oil pressure readings. Step 8 requires the technician to conduct the VTEC test again using the HDS following the brief period of holding the engine at 3,000 RPM. This repeated assessment is crucial as it verifies whether the previously noted issues have been rectified or persisted after allowing the oil system to stabilize and pressurize appropriately. The results of this second VTEC test will help in determining the effectiveness of any previous repairs or adjustments made. If the test indicates that the VTEC system is still underperforming, it is a clear signal that further investigation is required into the EOP sensor's functionality or the rocker arm oil control valve's operation. Therefore, effectively interpreting the results from this diagnostic step is key for guiding subsequent troubleshooting efforts aimed at addressing the DTC P2647 effectively. In the 9th step, the technician is tasked with checking the oil pressure reading obtained from the special tools connected to the EOP sensor. The expected oil pressure should rise to 392 kilopascals, kPa, equivalent to 56.9 pounds per square inch, psi, or 4.0 kilograms per square centimeter, kgf per centimeter. Achieving this pressure is crucial for the VTE system to operate effectively, as insufficient oil pressure may lead to malfunction or inadequate performance. If the pressure meets or exceeds the specified threshold, this suggests the EOP sensor is not faulty, and the next logical step is to replace the rocker arm oil pressure sensor. However, should the oil pressure fail to meet expectations, the focus shifts toward the rocker arm oil control valve, which would need replacement as it likely indicates blockage or malfunction preventing adequate oil flow. This assessment is a critical juncture in diagnosing DTC P2647, as it drives the decision on which component to address next. The last troubleshooting step reiterates the importance of safety by requiring turning the ignition switch to the lock position once again after completing the necessary interventions. This practice protects both the technician and the vehicle's electronic systems at the conclusion of the diagnostic process. Furthermore, this step signifies that the vehicle systems should no longer be powered on, allowing the technician to safely examine any components replaced or repaired. Whether the rocker arm oil pressure sensor or rocker arm oil control valve has been addressed, It is essential to ensure all work is completed to manufacturer specifications, and all tools and parts are correctly reassembled. Following proper protocol not only enhances safety during maintenance procedures, but also assures the quality and reliability of the repairs performed. After addressing the issues identified by DTC P2647, it's critical to conduct a final verification process to ensure that all repairs have been effective and the vehicle is functioning properly. This involves performing final diagnostics, essentially running through the initial steps of checking the engine oil level, conducting the VTEC test, and ensuring oil pressure is at the specified level. Confirming that any diagnostic trouble codes, DTCs, have been cleared is equally important, indicating that the repair work has resolved the underlying problems. Additionally, the technician should verify that there are no lingering electrical faults and that components, such as the EOP sensor and rocker arm oil control valve, are operating seamlessly. Completing this step efficiently ensures that the vehicle is returned in optimal working condition, thereby enhancing customer satisfaction and vehicle performance. Preventive maintenance is an essential practice to avoid future occurrences of DTC P2647 and ensure the longevity and efficiency of the VTEC system in Honda Civics. Regular oil checks should be prioritized as part of routine vehicle maintenance. Maintaining the proper engine oil level and quality is crucial for ensuring optimal VTEC operation. Moreover, ensuring that the oil is changed according to the manufacturer's recommended schedule can prevent sludge buildup and other particulate interference in the hydraulic control system. In addition, drivers should be encouraged to schedule periodic inspections of the rocker arm oil pressure sensor and rocker arm oil control valve. Adopted best practices in preventive maintenance will greatly minimize the risk of system failures and help keep the vehicle's engine running smoothly, leading to better overall performance and fuel efficiency. In summary, DTC P2647, indicating a VTEC system stuck on condition, reveals a specific malfunction within the variable valve timing system of the Honda Civic models from 2006 to 2011. Understanding the various causes, such as low engine oil levels, a malfunctioning EOP sensor, or faulty rocker arm oil control valves, is critical for effective troubleshooting. Following systematic steps to check oil levels, clear DTCs, conduct VTEC tests, and assess oil pressure readings allow technicians to isolate the root cause of the DTC reliably. Furthermore, adhering to preventive maintenance measures, such as regular oil checks and component inspections, is vital for sustaining the VTEC system's health. By integrating these key points, technicians can ensure optimal performance and reliability of the Honda Civics engine, ultimately enhancing the driving experience and vehicle longevity. Please like and subscribe to the channel. See you next time.